So in this video, I'm gonna go over some key things for us to remember. Um, Several of them are from Algebra 1, but some others will connect to uh, uh, elementary school years. So one is when you don't see that 2 in a radical, when you don't see it like in here, you know that there is a 2, and we read that as square root of 5. In general, if you don't see an index for the radical, you always know that there is a 2 there. Every number raised to the first power is the same number, so if you don't see that exponent, you always think there is a 1 there. And vice versa, if you see a 1, you can just leave it out and it'll be the same. That is true in general. And the next one, it's a way of thinking of this 1 over 2. We can think of that as one number. And what happens with that number written in that way is that when you multiply it by 2, you get actually 1. So everybody knows it's 0.5, but that's a way to think about that number. So in general, this will be like a number that multiplies by a gives you 1. So time for us to talk about reciprocal. So when you multiply two numbers and the answer that you get is 1, then you say that one number is the reciprocal of the other. So in symbols, if you have a times b and the answer is 1, then you call a the reciprocal of b and also b the reciprocal of a. Of course, we just said that this is a number that times a equals 1, so we know that this 1 over a is actually the reciprocal of a. This one here, for example, will be the reciprocal of 0.3 because we know that this number times 0.3 equals 1. And this number right here, 1 over 2/3, will be the reciprocal of 2/3, and that would be the way we write it down. And of course, we know also that when we multiplied a over b times b over a, if we remember from prior years, this you will multiply a times b over b times a, but those numbers are the same. And if the numbers are different from 0, division of those two will be always 1. So that means that a over b is the reciprocal of b over a. Reason why, when we multiply them, we get 1. Of course, same thing works backwards. So this new thing is gonna lead us to a property of exponents, another one. So I'm using definition of 2 to the 7th. So it's 2 times 2 times 2 multiplied 7 times. I grouped them differently and I simplified. If you remember from your prior years, we can divide by this common factor, 2 times 2 times 2 times 2. That's 4 2's right here will cancel out with 4 2's on the top. And the only thing that survives is 2 times 2 times 2. And that we can write as 2 to the third power. So this, we can do it maybe once or twice so that we understand it. But after that, we will look at the exponents 7 and 4 and we will figure out how to get the 3. It's not too hard to notice that you're subtracting 7 minus 4 equals 3. So in this case, 3 to the 5th over 3 to the 4th. I'll give you 1 second to guess it. And of course, yes, the correct answer would be 3 to the first power. As we said before, 3 to the first power equals 3. So in this case, we can even simplify more. So in general, to divide two powers with the same base, we actually do not add exponents as we did when we multiplied, but we actually do the inverse, which is subtract. So if they ask us to write this as a power of 5, we're going to keep the same base, 5, and we're going to subtract the exponents. It's important to realize that the subtraction needs to be written with the exponent at the top first minus the exponent at the bottom. If you change the order, the answer would be the opposite. So it would be -2, and that's not right. That's not correct. So what is the meaning of a to the 0 power? So let's analyze this. 2 to the third over 2 to the third, we know these numbers are not 0, so the division must be 1. That's on the one hand. But on the other hand, we just learned that we can also subtract. And we know that 3 minus 3 equals 0. So if on the one hand this equals 1, on the other hand this must be also 1. And that would be the meaning of any number different from 0 to the 0 power. So in general, we can say that if a number is different from 0, then when we raise it to the 0 power, that equals 1 every single time. And that helps us to get to the meaning of a negative exponent. So we know that this multiplication here equals 2 to the 0 power. On the other hand, we know that equals 1. So that means that, this is adding using the rule of multiplying powers with the same base, we add the exponents. So this here equals 1, 2. So we can say that one number times another number equals 1. We can say 1 is the reciprocal of the other. So 2 to the -3 is the reciprocal of 2 to the third. Reason why, when we multiply those two, we get 1. And we said that every time that happens, one number is the reciprocal of the other. So in this case, we got this. And we also have, in general, that if a is a number different from 0, a to the -n is the reciprocal of a to the n. So that means that in symbols, we're going to write down 1 over a to the n. So when you see a negative exponent, you can always change it into a fraction. Then the numerator will be 1 always. The denominator will be the same power, now with the exponent, with the sign of the exponent changed. So far we got some properties, and I know I've been going over these kind of quickly, but you can stop the video and watch it at your own pace. So any number raised to the first power is the same number. To multiply powers with the same base, you keep the same base and add the exponents, so addition. When you are dividing, because division is the inverse of multiplication, then you don't have to add the exponents anymore. You actually subtract the exponents. Also, for any number different from 0, when you raise it to the 0 power, that equals 1. And the last one is the one that we just covered. So hopefully that'll help you to keep things in the right place.